Raise this for Drew, because I like the conversation we just had. All right. Does n equal 1 generate the first term?
Yeah.
Okay, does n equals 1 generate the first term? And then that's your first condition. If that doesn't work, great trick question for the test. I put in one that doesn't work for 1, but does work here. You forget to check 1, and you waste a lot of time getting the wrong answer. This is what that second step looks like in most of the cases, except for the ones we're looking for the factor. Yes, sir?
How many are we supposed to check?
How do you mean? Oh, how many terms you're supposed to check?
Yeah.
You should only have to check 1 unless you get 0. For some of them you got 0, and then it still worked after that. Now this phrasing on the second one, does the sum of the first k terms plus the next term equal the sum of the k plus 1 terms? Yes?
You just said that a nice trick question or whatever on the test would be if it doesn't work for the first part.
Yes.
What if it equals 0?
Except equaling 0 can still work. The book
Okay,
had
so
some examples of that.
only if it equals 0. Okay, because
I'm not sure yet. Middle of next week? Hoping that'll be 2 weeks from the last one.
But you said that if it's 0, how can we know if it doesn't work or not? Is it up to the next term?
Yeah, go to the check the term after 0. That's for the ones really if you're seeing if there's a factor, like will the expression always generate a number divisible by 2?
Okay.
And a question like that can still work. For these, it's less likely to. And you do something slightly different from these. Now,
Are we going to go over that?
yeah, well, let me do a slightly easier one first, because I don't want to do that one. I want to do one of the ones that was in the homework. I'll do this one because it had a good trick. The question I'm going to ask is, does some people have asked about this. Here's my example. 1 plus 3 plus 3 squared plus 3 cubed plus dot dot dot. I'm going to do the exponent one, Adina, that we did this morning before I do 30. This one's a little easier. 3 to the n minus 1 equal my summation formula. 3 to the nth minus 1 over 2.
Okay, just kidding.
Now, for this problem, this is my term generator. Here's the notation I didn't give before. This is your a sub n. Remember that from the first day? This is what generates each term. This is your sum formula up to the nth term. So use the notation we did on the first day. Okay, so another way to say this is if a sub n equals 3 to the n minus 1, does s sub n really work as a summation formula? Now, next thing. So, step 1. Okay, please go around next time. Okay. Okay, does n equals 1 generate the first term? 3 to the first power, minus 1 over 2. Does this equal 1?
By the way, this thing is filming cookies.
That's okay. Yes, does everyone agree with Lauren?
Yes.
Okay, good. Now, 2. Okay, does, second part, our summation formula with k in it. 3 to the k minus 1 over 2. James, this is one you and I did earlier. Plus the next term. This is my a term generator, a sub n. So my next term is going to be 3 to the k plus 1 minus 1. Does this equal the same thing as if I just plug k plus 1 into my sum formula?
Yes.
Okay, the answer is yes. We're going to prove it very quickly. But any questions on what I plugged in here? My sum formula with k, my next term by my a sub n formula equal to my sum formula with k plus 1. Yes, sir?
Where did that term come from?
Which one?
The plus 3. That,
This one? 3k plus 1? Okay, back over here a sec. Dina, follow me?
Oh, this is what you were doing yesterday?
Yeah, I'm reviewing it quickly because I got to get the new stuff as well. This is my term generator. A sub n equals 3 to the n minus 1. A sub 15 is my 15th term. Put 15 in here. All right. This I want the sum up to some number plus the next term. If this number's 10, I want this to be the 11th term. If this number's 15, I want this to be the 16th term.
Okay.
So I've got to put k plus 1 into my term generating expression.
Why is it A not S? Why would it be
S means sum, A refers to the term. A sub 10 means the 10th term, S sub 10 means the first 10 terms added up.
If it was 1 plus 5 squared plus, would the 3 there be 5?
Yes.
So,
Yes.
didn't you use your sum generator? Shouldn't you have used the term generator for the first thing?
No, this is the sum.
Top.
Top.
No, because you was only.
No, the one you test is the sum generator.
How did you get to the?
Oh, I thought you tested.
No, you test the sum generator, not the term generator.
To make sure you get the first.
Make sure you get the first. Well, the sum of the first term should be the first term. Yeah, that's because the sum is what you're testing. Yes.
Okay, how that middle part in the second step? Where did that come from?
Okay, if this were the 10th term, here's what we're checking. This expression means add up the first k terms. So if k were 10, this would be the sum of the first 10 terms.
Okay.
To that, I would like to add the 11th term. So the 11th term is going to be my term generator with k plus 1 in it.
How do you know that's
Okay,
the
but
11th
with
term?
that minus
Well, it doesn't matter what it is. I'm making up those
Well,
numbers.
yeah, the
It could
minus
be
one
10
makes
and
the one go
11.
away,
It
but
could be
that's just a
57 and
mathematical
58.
Okay, where's the minus 1 come from though?
That is in the term generator. That was given to us. Okay. Now, Cody, the sum of the
Would
first
that
10.
minus 1 cancel that plus
It
1?
will in a moment. I'm
Only
just showing the
k,
step.
But then would you replace k with k plus 1?
Hold that thought. I'll get through that. I'll do that very quickly now, but I'll hold that thought a second. My sum generator plus my 11th term should equal what my sum generator gives me if I plug in 11. This means add up the first k terms. Let's pretend that means 10.
So if you were actually to plug in 11,
10 and 11, it should equal the same as if I put 11 here. If I were to actually plug in
Okay.
52 and 53,
that part makes sense.
it should equal what happens if I put 53 in here. But we have to prove it in general. We can't prove it for any two numbers. Okay, so now, very quickly, this one's a little bit tricky. It requires you to remember something from way back when. Now, I'm going to make a common denominator, and as
Where does that 2 come from?
I'm doubling the top and bottom of this fraction
Okay.
to make a common denominator. And this still has to equal 3 to the k plus 1 minus 1 over 2. Does anyone here think I should make this 6 to the k?
No.
Thank God. Okay, order of operations, exponents first, then multiplication. Got to deal with that first.
Well, does that make it?
Well, here, check out what I've got here. I've got 2 times 3 to the k plus another 3 to the k.
But this might be a really stupid thing, but does that make it 3a? Like the.
Which
k
part?
to the 3 to the k exponent, yeah.
Where did
How do
they-
you like do a k exponent of a number?
You don't. You leave it as a variable for now. But I'll check. You can't figure this out unless you know what k is. But there is a trick you can do here. Okay? I've got 2 of something plus a third of that same thing. Just going back to Algebra 1, that means I have 3
How do you have the
of that thing. If I have 2 of anything, Cody, plus another 1 of that thing, I have 3 of that thing.
But where's the minus
Wait,
one?
you said a third.
Because there's no minus
Oh,
one.
because that's actually 1 times
Oh,
3 to
a
the k
third,
plus
not-
2.
Yeah.
Not the fraction third.
Martina.
Never mind.
There's no. Okay, where do you get the 3k?
This here,
Yeah.
k. I put k plus 1
Right.
into my
right.
subgenerator,
Okay,
the
you
plus
just
1
got rid
minus
of
1.
Okay,
Yep.
yeah.
Okay. Now that I know I have 3 of these, I can make this. What is 3 to the first power times 3 to the k power? What can I do with those exponents?
Oh, k plus 1.
I can add the exponents. Very good, Lauren. And now, this side is equal to this side. This formula will always work.
Woohoo!
Okay.
Yep.
Alright.
Okay?
Sure.
I've got to move
Wouldn't
forward,
it be
unfortunately.
9 though?
No. Nope. 3 to the first times 3 to the k.
That's the same thing as that.
Yep.
Ow.
Making this 9 would be like saying I could multiply before I dealt with the exponents. You know PEMDAS says that's not possible.
But how is that equal to that when you got the multiply?
Same
Oh,
base,
you
add the exponents.
What does PEMDAS even stand for?
Please excuse my dear Aunt Sally.
Or parentheses.
Parentheses, exponents, multiplication, division, addition, subtraction. What I don't like about it is really multiplication is not above division and addition is not above subtraction. They're actually equal.
So you
What's
do-
the other one? The
No,
short
you
one.
do it from left to right, don't you?
Yeah,
What else?
but sometimes you can